Today we're going to be talking about the unit circle, something that you may already be familiar with, but we're going to talk a little bit more deeply about how to use it and what it tells us. So the first thing I want you to do is write down everything about this image that you notice, and then also write down everything that you wonder about it. So get out a piece of paper, pause the video, and just write down everything that you notice and everything that you wonder. So as you might already know, this is the unit circle. It's got a radius of 1, so every point on here is 1 unit away from the center of the circle. And so that's why it's called the unit circle, is because it's got a radius of 1 unit, so it's a unit circle. And yes, so everything is 1 unit away. You'll also notice that certain points on this circle are shown. The northernmost, the southernmost, the easternmost, the westernmost, you could say top, bottom, right, and left points are labeled, and then also the points halfway between those points. So maybe the north, you could say northeast, northwest, southwest, southeast. Those points are labeled, and then also the points that are 1/3 and 2/3 between these two sides. So that's this point here, square root of 3 over 2, 1/2, and 1/2 square root of 3 over 2. Those are this is the 1/3 and 2/3 of the way from here, from the x-axis to the y-axis, I guess. So we have a couple points he labeled here, and then it seems to also repeat the same numbers over and over again. You'll notice that in red here we have the square root of 2 over 2, or the negative square root of 2 over 2. We have 1/2 and negative 1/2 in yellow, and square root of 3 over 2 and negative square root of 3 over 2 in green. It just seems to repeat those numbers over and over again. So, and then we also, on the sides, we also have 1s and 0s and negative 1s. And then there's also other numbers on here. There are the angles that there's lines drawn to these points, these special points that we've labeled in, and then we have also the angle that these points make with the positive x-axis. You can see like those angles, a couple of those angles highlighted in purple and with the red arc. So these angles seem to be, specially labeled. There are 360 degrees, so this is 330, and the next one will be 360, which is just back at 0. There's also 2 pi radians. So each circle every circle has 2 pi radians, is another way of describing the angles. And there's something special about this 2 pi radians. So the formula for the circumference of a circle is C circumference equals 2 pi r, or radius. So 2 pi times the radius. The radius of this circle we know is 1. So 2 pi times the radius would be just 2 pi. So this circle, the unit circle, has 2 pi radians as the angle all the way around would be 2 pi radians. That's this red arrow. But then also the circumference is 2 pi units. So the circumference is 2 pi. And so there's a direct correspondence between the angle measure in radians and the length of that arc. So we would expect that halfway around the circle should be half the circumference. The circumference of the circle was 2 pi. So half of that is just pi. And then what's that angle measure? Half is just pi. So the angle matches with the angle with the length of the arc. So a quarter radian circle would be a quarter of the circumference. So 2 pi divided by 4 is pi over 2. And the angle in radians is pi over 2. They just match up. So as I said, you can tell the arc length of an angle by what the radians is. So if you can see this green line is the length of the of whatever angle. And if we want to make a bigger circle, we could just multiply that angle by the radius. So if we want to do all the way around the circle, that the angle in radians there is 2 pi, and so 2 pi times the radius would give us the circumference of the whole, all the way around the circle, the length all the way around the circle. If we want to do halfway around that circle, we just do pi times the radius of the circle. So why do we care about the unit circle? You might be asking. That may be one of the things you wrote down that you wondered. And one thing that you might have noticed is that each of these lines, each of these angles here, these special points, you could make a right triangle, like I have in green here, just by drawing a line straight down. And each in-between line makes a right triangle with a hypotenuse of 1. So you could figure out the this angle in the corner here is 30 degrees, just by doing that. This is 150 degrees and that's the 180 degrees, so the difference between that should be 30 degrees. And now that's enough information to start doing some trigonometry. What is the sine of 30 degrees? Well, sine is opposite over hypotenuse. So it's going to be the length of this red line. The sine of 30 degrees is going to be the length of this red line divided by the length of the long black line, the hypotenuse, which the hypotenuse we already said was 1. And the length of so sine would just be the opposite divided by 1. So anything divided by 1 is just itself. So the sine of 30 degrees would just be the height of the red line. And the height of the red line is exactly the y value of the point, which is 1/2. And so the sine of 150 degrees, that's why this is so helpful, is that actually this tells us the sine of 150 degrees is also 1/2. It tells the sine of this 150 degrees angle is going to be the length of the opposite side, which is this red line, which will be the y value of that point on a unit circle. We might also do the same thing with cosine. What is a cosine of 30 degrees? Well, that would be the adjacent over hypotenuse. So that would be adjacent divided by 1. The hypotenuse is still 1. And so then cosine must be the length of this adjacent side from the bottom of the red line to the center of the circle. And the length of that side is actually just the x value of this point. And since we're on the negative, normally the cosine of 30 degrees would be square root of 3 over 2, but since we're on the negative x-axis, the square root of 150, or the cosine of 150 degrees, would be the negative square root of 3 over 2. So we can use the unit circle to find out the sine and cosine of all 360 degrees. And so yeah, so basically what we found out here is that sine and cosine are just the x and y values of each of these points on this unit circle. So these labeled points, that's kind of why they look kind of funny, but they might look familiar as well, is that they are the x value and y value. And that's really useful to know. And this even works for 90 and 180 and 270 degrees and 0 degrees even. Even though we couldn't really make a triangle that has where one of the angles is 180 degrees, we can still figure out the sine value or the cosine value. The sine value of 180 degrees would be negative, or would be 0. That would be sine of 180. And then the cosine of 180 degrees would be negative 1. Or we could say the cosine of pi radians is negative 1. We can talk about radians because we're mathematicians. And this green triangle that we made with the 150 degrees, or we can make it with any of these other points, or these are called reference triangles. I like to call them bow tie triangles because they make a little bow tie on the circle. So you might be asking, so should we memorize this unicircle? And then that, like, why, still don't understand the point. I mean, if you want to memorize the unicircle, you can, for sure. That sounds like a lot of work, though. You actually really only need to know the first quadrant to know the rest. Everything else, and you could find out the first quadrant by doing these 30, 60, 90 triangles or 45, 45, 90 triangles. Because everything else is just the same numbers, just different orders. And so you can use the bow tie triangles to figure it out. So here's some questions to think about, some follow-up questions. How could you use these points on the unicircle to find the points on a larger circle? So if you wanted to know what point would be at 135 degrees on a circle with a radius of 2, where would that point be and how would you figure that out? And I'll give you a hint, it has to do with the similar idea of what we had to do to find the arc length. And then give a process using this information that we know about how the circumference is related to the arc, or the arc length is related to the angle in radians. Give a process for converting between radians and degrees that isn't just that, like, actually explains where the numbers come from. Don't just say multiply by whatever number. Say why you multiply by these numbers. And then finally, what would change if we drew our reference angles the other way? So what if we drew our angle from here to here and talked about this triangle? What would be different? And why don't we do that? Why do we always go straight down? So those are some questions to think about. I'll see you in the next